We're going to do 10 practice problems for AP Physics 1, Unit 2, forces. We have a 5 kilogram block that rests on a horizontal surface. A horizontal force of 20 newtons is applied, and the block accelerates at 2 meters per second squared, and we want to find the frictional force. Well, what we're asked for here is that we can just use our net forces because we are looking at this system as a whole. So we know that our mass was 5, and we know our acceleration was just 2. So this will give us a net force of 10. So we know that we have an applied force as well, which was 20 newtons. And because we know that this is going to be in the opposite direction, we have a force of friction that is acting against our motion. So when we combine that together, we have 20 newtons minus the force of friction is equal to 10 newtons. So if we solve for force of friction, then you get that force of friction is equal to 10 newtons. So that is how we know that we have option B. We have a 3 kilogram object is moved with a constant force on a frictionless surface. Its velocity increases from 2 meters per second to 8 meters per second in 3 seconds. We want to know the applied force that this object experienced during that time. So we have a relation of time, and we also have a v speed. So we know that delta v over t is equal to acceleration. So we can just find acceleration by using those two v's that we were given. We have 8 minus 2 divided by 3, which is 2 meters per second squared. And we can use our forces equals to mass times acceleration. So you just have 3 times 2. And that is going to be 6 newtons, which is your force. A block rests on an incline. So which of the statements has to be true? Well, if it's at rest, that means that we have balanced forces because there is no acceleration up or down. Your acceleration in its sum, its magnitude, is going to be just 0. So when you just take your net forces, that's going to equal to 0. So that means your normal force here, it also does not equal to your weight because in this scenario, your weight is acting at the center of mass. It's at an angle. However, your normal force is just straight perpendicular. So you're actually going to have components here that are broken up, and then you have to balance those vertical forces, this Fn cosine theta, and also this Fn sine theta, or you can just say Fg. This is your Fg, I mean. So those vertical forces have to balance, and if you had friction acting up the incline and your acceleration was in the downward direction, then you would have to balance those as well. You had a Fa in this direction, for example. So in this case scenario, though, you just have that it is going to have a net force of 0. Now, we have 2 blocks that are connected by a string over a pulley. One of the masses is going to be larger, and which of the following is true? So we just know that if you have your larger mass, it's going to have a larger weight because on anything, you are going to have a weight that is equal to the mass of that object times the gravitational constant, which is always going to be the same. So your system is going to accelerate towards the mass that is heavier, saying m1 is greater than m2, for example, and this is mass 1, and this is mass 2. So we would have acceleration in this direction, and we could make that positive so we could solve. So we are going to be going on the heavier side. Now we have a box that slides down a rough surface at a constant velocity. So that means your frictional force is not equal to 0. So if we're going down, we have to know that acceleration is equal to 0 because the key word here is you have a constant velocity. So when you have your change in velocity, if you have, for example, 5 minus 5, that is a constant number. So then that difference between those two numbers is equal to 0. So when you divide it by anything by 0 divided by anything, you still get 0. So that is how you know your net force is equal to 0, because when you take F is equal to ma, that's your net force. You plug in 0, you see that your F net is equal to 0. So we have a 10 kilogram object in an elevator is accelerating upward at 2 meters per second squared. We want to know what the normal force is on the object. So let's draw our elevator here. We are going to go up. So at the center of the elevator, we have our force of gravity, mg, and then we also have the object inside of the elevator, which is going to have an upward net force, or an upward force that is normal, perpendicular to the surface, Fn. So let's sum our forces. We have the summation of forces, ma, of course. So we have Fn acting up, and we have mg acting down. That's equal to ma. So then if we just solve for Fn, we have ma plus mg. So then you can factor out an m right here. You're left with a plus g inside. So now all you have to do is just substitute in your values. You have your normal force is equal to your mass of 10 plus an acceleration, or you have 10 here plus 2. We'll use gravity as approximately 9 as 10 because that's what you can do for MCQ questions. You have 2 for your acceleration. That's going to give you 120 newtons right here. So we have a rope that pulls a box with a force T, and then the box pulls back with a force F. So what is going to be true? So this is just a Newton's third law question, which states that all the forces that we have that are in pairs, it's going to be equal and opposite. So equal in magnitude and then opposite in direction. So when we have the rope pull on the box is going to pull back on the rope with an equal magnitude, so T is equal to F. Now, a car rounds a flat curve at a constant speed. Which of the forces provide the centripetal acceleration? So we are at a constant speed. That's you have to consider. You are going to have your net forces, your centripetal forces equal or pointing towards the center. You're also going to have acceleration directed toward the center. And when we have centripetal questions, we always make our positive direction for acceleration be towards the center because that is where our acceleration is pointing to. So when you have a flat curve, your FC is equal to mv squared over r, and that's just your in general formula for centripetal motion. Well, we have this object and we have Fn acting upward, we have Fg acting downward. Fn and Fg are going to be equal to each other, and your Fc, this is not a new force, but this just describes the sum of your net force. Centripetal is an adjective, so this is actually your force of friction that is going to be acting towards the center, and this is going to be static, so that is going to be directed in this direction. That's going to be what's causing your centripetal motion. Your Fn and Fg, they're going to cancel out and equal to one another. So our answer is friction provides a centripetal force. That's because you're moving around in a banked direction. You have velocity that's tangential to the point, and when you're going around, you're gonna have you have an inertia that makes you want to go away from the center of mass, but that static frictional force is going to keep pulling you back in and keep you moving in a circle. So you have a block that is being pulled up an incline at a constant speed. What do you know is true? So constant speed, again, that's just delta V over T. You know the change in two constant numbers, same numbers, is the difference is going to be 0. So then you just have that your acceleration is 0. So when acceleration is 0, we know that F net is equal to 0 because F is equal to ma, right? So then that means that the friction here is going to act down the incline because we know that we are moving up the incline. So friction is down and the opposite of that upward movement. So friction acts down. So we should say down. A 2 kilogram object is acted on by forces 10 newtons and 6 newtons to the left. What is the acceleration? So if we know that they're both in the horizontal direction, you have 6 newtons this way and you have 10 newtons this way. You can just subtract them, the difference. We're going to make our positive direction as the right. So then you just have 10 minus 6 is equal to 4 newtons to the right. So that is your net forces. So when you take your acceleration, that's going to be your net divided by your m, which is 4 over 2, aka 2 meters per second squared in the rightward direction, since we received a positive number and we defined positive as towards the right. So that's going to be 2 meters per second squared right. Here your net force is equal to 0, so that would have been one of your answers, and you could also make this your answer as well for option D, for question D.